So in this third video, in the topic of surds, we are going to look at the process of adding and subtracting surds. Now, it's not quite as simple as adding or subtracting numbers. This is very similar to the process of collecting like terms, which we've experienced in algebra. So we have to first of all consider whether you are able to add or subtract a particular series of surds. So we can only add or subtract surds where the same value is inside the square root. So we're only able to add things that are exactly the same. So I couldn't, for example, add the square root of 2 to the square root of 3 to give me the square root of 5. I would simply just have the square root of 2 plus square root of 3, and I couldn't simplify that any further. So the first thing we want to do in order to add or subtract surds is we just want to check that we have the exact same value in the square root. Those are the only things we can combine together. So looking at these two examples, the first one I have root 2 plus 2 root 2. So yeah, I've got root 2 here and I've got root 2 here, so that is now in the form that I can add them together. I just have to at that point keep track of how many square root 2's I have. So remember that in any kind of algebra, if I have root 2 written by itself, like if I had x written by itself, we don't really write the number 1 as a coefficient. So that's 1 root 2. So I have 1 root 2, I add 2 more on, so I have 3 root 2. My next example, I have 3 root 5, take away 2 root 5, add on root 5. So root 5, root 5, root 5, I am able to add these. So to keep track, I have 3 root 5, I take away 2 of them, so I now have 1 root 5 left, and I add 1 more back on, so that means that I have 2 root 5 as my final answer. Okay, so to look at some slightly more involved examples here. So if we're asked to add or subtract surds that have a different square root value, we need to simplify some of them or all of them to put them in that form. Now, let me look at this little hint I've put here. In some cases, one surd will already be fully simplified, and that will tell you how to simplify the others. So if I look through these surds, I have the square root of 20, I have the square root of 5, and I have the square root of 45. Now root 5 is a surd that can't be simplified anymore. So that suggests to me that in my answer I want to have a certain amount of root 5's involved. So I'm going to simplify down root 20, and I'm going to simplify down root 45. I'm going to hopefully end up with an amount of root 5 each time. So here I have the square root of 20. I'm going to write off to the side just to do this. So it's root 20. If I was to take root 5 out of that, 5 watts give me 20. Well, that's 5 fours. And as I would have hoped, root 4 is a square. Make that a little bit. So I can simplify that down to 2 root 5. Again, one surd might well give you hints towards what to do with the others. So now I have root 45. So let's again assume that I can take root 5 out. 5 times what is 45, so we think about our 5 times table, and that's 5 nines. So root 45 is equal to root 9 times by root 5. And root 9 is a perfect square. That gives us 3 root 5. So I now have 3 surds that I can write in terms of a number of root 5. So I have root 20, which is 2 root 5. Take away root 5, add on root 45, which is 3 root 5. 5, 5, 5, I can add and subtract these. So I have 2 root 5s. If I take one away, I'm left with 1. And if I add on 3 of them, I will have 4 root 5 as my final answer. Now, to make it slightly more involved here, I have root 27, I have root 12, and I have root 48. None of those are already fully simplified. So what I am looking for here is I am looking for the easiest surd out of those 3 to simplify. Okay, there's no point just randomly trying to simplify them all if you can find a way that gives you a clue. So the smallest number there is root 12, so I'm going to try and simplify that first. Root 12. Are there any square numbers which divide into 12? Well, I have 1 and 12, neither of those are square. I have 2 and 6, neither of those are square. And I have 4 and 3. So that's root 4 by root 3. So root 12 is equal to 2 root 3. Let's do root 27 now. So I have root 27. Again, I'm assuming that 3 comes out of it. 3 times 9 will give me 27, so that's root 9 root 3, which is equal to 3 root 3. And the last one I will look at is root 48. I've left the biggest one till last. So root 48, if I take a 3 out of it, that is 3 times 16, or 4 root 3. So now I have the square root of 27, take away the square root of 12, add on the square root of 48. I have those written with the same surd involved in all of them. So I rewrite that as being equal to 2 root 3, take away, oops, I've made a mistake here. This is what happens because I wrote them in a different order in my working than they were initially, so again, watch out for that. 27 is 3 root 3. And 12 is 2 root 3, so take away 2. Root 3 and 48 is plus 4 root 3. So now let's go through and simplify. So 3 root 3's, if I take away 2 of them, I have 1 left. And if I add 4 more on, I end up with 5 lots of the square root of 3. And that's now fully simplified, and you can use that as your answer.